Hello, this video will show you how to run Delphi example 3 and the usage of FRC function. All the example files and software can be downloaded from Delphi software website. It's compbio.clemson.edu/Delphi. After you download and unzip the example files, you will find example 3 FRC. In this folder, we have our FRC1 example and FRC2 example. Today, I'm going to show you the FRC1 example. In this folder, we have 5 files, a FRC in file and 3 parameter files, the charge, PDB, and size, and a parameter file. Before we really get into the example, I'm going to explain the function of FRC. If we have a system including 2 atoms, N1 and N2, the potential, charge, salt concentration, and many other properties at point N3 can be calculated by using FRC function. So to use this function, we will need an actual input file called frc.in. In this frc.in file, we have a coordinate. It's called N3. It's actually the coordinate of the point of interest. So in this example, the N3 is at 0, 0, 0 in figure 1. So here N3 is 0, 0, and 0. The coordinate file of the other 2 atoms is in the my.pdb. It's 550 and 500. And the charges and size of the other 2 atoms are in the charge and size file. Since I have already explained the charge and size files in the previous examples, I will go ahead and into the parameter file. In the parameter file, we have grid size, scale, and the input files. So in addition to the 3 normal input files, we have another input file. FRC file is frc.in. We still have the internal dielectric constant, external dielectric constant, probe radius, salt concentration, boundary condition, max convergence, output file, energy files. So we need to pay a little bit attention here. We have an addition line called site AFP and the output file FRC file equals to frc.out. In the site AFP, this one defines what kind of functions we want to calculate. A is the atom, F is the force, and P is the potential. We have many more properties can be calculated, so the details can be found in the user's manual. The output file is the frc.out. The format in this file is some header plus a PDB format. So after we look at the parameter files, we can type in the Delphi executable file plus the parameter.txt. It is that simple. And after 370 iterations, the simulation is completed. We have the frc.out. So in the frc.out, we have some headers explain what functions or properties are calculated, and an atom N3 at grid point and grid fields. So that's grid potential is PT. And the grid fields is the force on this direction. Right, we can also compare the number from numerical iterations to the analytical solution. It's quite accurate. You can find this file in the folder too. If you cannot find it, contact Delphi email to get some detailed explanations. So here we are coming to the end of Delphi example 3. In the next video, I'm going to show Delphi example 3 and FRC 2. In FRC 2, we'll calculate another FRC for a real protein. In the other one, I'm going to show you how to calculate the force and potential in many grid points around the protein. And thank you for watching, and thank you for your support to Delphi software.